This article is about the important technologies that have historically increased productivity. Productivity in general is a ratio of output to input in the production of goods and services. Productivity is increased by lowering the amount of labor, capital, energy or materials that go into producing economic goods. Increases in productivity are largely responsible for the increase in per capita living standards. History. Productivity improving technologies date back to antiquity, with rather slow progress until the late Middle Ages. Important examples of early to European medieval technology include the water wheel, the horse collar, the spinning wheel, the three-field system and the blast furnace. All of these technologies had been in use in China, some for centuries, before being introduced to Europe. Technological progress was aided by literacy and the diffusion of knowledge that accelerated after the spinning wheel spread to Western Europe in the 13th century. The spinning wheel increased the supply of rags used for pulp and paper making, whose technology reached Sicily sometime in the 12th century. Cheap paper was a factor in the development of the movable type printing press, which led to a large increase in the number of books and titles published. Books on science and technology eventually began to appear, such as the Mining Technical Manual de Re Metallica, which was the most important technology book of the 16th century and was the standard chemistry text for the next 180 years. Francis Bacon is known for the scientific method, which was a key factor in the scientific revolution. Bacon stated that the technologies that distinguished Europe of his day from the Middle Ages were paper and printing, gunpowder and the magnetic compass, known as the Four Great Inventions. The four great inventions important to the development of Europe were of Chinese origin. Other Chinese inventions included the horse collar, cast iron, an improved plow and the seed drill. See also. List of Chinese inventions. Mining and metal refining technologies played a key role in technological progress. Much of our understanding of fundamental chemistry evolved from ore smelting and refining, with the Re Metallica being the leading chemistry text for 180 years. Railroads evolved from mine carts and the first steam engines were designed specifically for pumping water from mines. The significance of the blast furnace goes far beyond its capacity for large-scale production of cast iron. The blast furnace was the first example of continuous production and is a counter-current exchange process, various types of which are also used today in chemical and petroleum refining. Hot blast, which recycled what would have otherwise been waste heat, was one of engineering's key technologies. It had the immediate effect of dramatically reducing the energy required to produce pig iron, but reuse of heat was eventually applied to a variety of industries, particularly steam boilers, chemicals, petroleum refining and pulp and paper. Before the 17th century, scientific knowledge tended to stay within the intellectual community, but by this time it became accessible to the public in what is called open science. Near the beginning of the Industrial Revolution came publication of the Encyclopédie, written by numerous contributors and edited by Denis Diderot and Jean-Laurent d'Alembert. It contained many articles on science and was the first general encyclopedia to provide in-depth coverage on the mechanical arts, but is far more recognized for its presentation of thoughts of the Enlightenment. Economic historians generally agree that, with certain exceptions such as the steam engine, there is no strong linkage between the 17th century scientific revolution and the Industrial Revolution. However, an important mechanism for the transfer of technical knowledge was scientific societies, such as the Royal Society of London for Improving Natural Knowledge, better known as the Royal Society, and the Académie des Sciences. There were also technical colleges, such as the École Polytechnique, Scotland was the first place where science was taught and was where Joseph Black discovered heat capacity and latent heat, and where his friend James Watt used knowledge of heat to conceive the separate condenser as a means to improve the efficiency of the steam engine. Probably the first period in history in which economic progress was observable after one generation was during the British Agricultural Revolution in the 18th century. However, technological and economic progress did not proceed at a significant rate until the English Industrial Revolution in the late 18th century. And even then productivity grew, about 0.5% annually. High productivity growth began during the late 19th century in what is sometimes called the Second Industrial Revolution. Most major innovations of the Second Industrial Revolution were based on the modern scientific understanding of chemistry, electromagnetic theory and thermodynamics, and other principles known to a new profession of engineering. Long-term decline in productivity growth. The years 1929 to 1941 were, in the aggregate, the most technologically progressive of any comparable period in U.S. economic history. Alexander J. Field, as industrialization has proceeded, its effects, relatively speaking, have become less, not more, revolutionary. There has, in effect, been a general progression in industrial commodities from a deficiency to a surplus of capital relative to internal investments. Alan Sweezy, 1943 U.S. Productivity growth has been in long-term decline since the early 1970s, with the exception of a 1996 to 2004 spike caused by an acceleration of Moore's law semiconductor innovation. Part of the early decline was attributed to increased governmental regulation since the 1960s, including stricter environmental regulations. Part of the decline in productivity growth is due to exhaustion of opportunities, especially as the traditionally high productivity sectors decline in size. Robert J. Gordon considered productivity to be one big wave that crested and is now receding to a lower level, while M. King Hubbert called the phenomenon of the great productivity gains preceding the Great Depression a one-time event, because of reduced population growth in the U.S., and a peaking of productivity growth. Sustained U.S. GDP growth has never returned to the 4% plus rates of the pre-World War I decades. The computer and computer-like semiconductor devices used in automation are the most significant productivity-improving technologies developed in the final decades of the 20th century. However, the contribution to overall productivity growth was disappointing. Most of the productivity growth occurred in the new industry, computer and related industries. Economist Robert J. Gordon is among those who questioned whether computers lived up to the great innovations of the past, such as electrification. This issue is known as the productivity paradox. Gordon's analysis of productivity in the U.S. gives two possible surges in growth. One during 1891 to 1972 and the second in 1996 to 2004 due to the acceleration in Moore's law-related technological innovation. Improvements in productivity affected the relative sizes of various economic sectors by reducing prices and employment. Agricultural productivity released labor at a time when manufacturing was growing. Manufacturing productivity growth peaked with factory electrification and automation, but still remains significant. However, as the relative size of the manufacturing sector shrank, the government and service sectors, which have low productivity growth, grew. Improvement in living standards. Chronic hunger and malnutrition were the norm for the majority of the population of the world, including England and France, until the latter part of the 19th century. Until about 1750, in large part due to malnutrition, life expectancy in France was about 35 years, and only slightly higher in England. The U.S. population of the time was adequately fed, were much taller and had life expectancies of 45 to 50 years. The gains in standards of living have been accomplished largely through increases in productivity. In the U.S., the amount of personal consumption that could be bought with 1 hour of work was about $3 in 1900 and increased to about $22 by 1990, measured in 2010 dollars. For comparison, the U.S. worker today earns more working for 10 minutes than subsistence workers, such as the English mill workers that Frederick Engels wrote about in 1844, earned in a 12-hour day. Decline in work week. As a result of productivity, the work week declined considerably over the 19th century. By the 1920s, the average work week in the U.S. was 49 hours, but the work week was reduced to 40 hours as part of the National Industrial Recovery Act of 1933.